When you think of the sun, you probably imagine a solid, reliable source of light and heat. But this is just an average day for our star. Every day it undergoes many explosions on its surface that can disrupt important systems on Earth, from knocking out satellites to interfering with radio communications. And while most of these eruptions are fairly small, every once in a while the sun will have a really bad day. This is what we call a solar flare. Let's start by explaining how these events occur. The sun isn't like a typical ball of fire. It doesn't burn fuel or produce heat in the same way a furnace does. Instead, it generates energy through nuclear fusion in its core, where hydrogen atoms combine to form helium, releasing tremendous amounts of energy. That energy radiates outward through the sun's layers and eventually reaches the photospheric layer, which is the visible surface of the sun. Here, the energy causes a constant churning motion. Regions of hot plasma rise up and cool off before sinking back down and heating up again, creating a cycle that never seems to end. This is known as convection. But wait, plasma. We thought the sun was made of hot gas. Plasma is actually just another state of matter where some or all of the electrons in a gas have been stripped away from their atoms. So when we say the sun is made of plasma, we mean it's mostly made of plasma. This convection process happens over active regions on the sun, areas with strong magnetic fields that emerge from the churning plasma. These fields twist together and loop hundreds of thousands of kilometers into the sun's atmosphere, creating stars. These dark areas appear cooler than the surrounding photospheric temperatures because they're actually opaque, blocking light from coming through. Now, remember how we said the sun is covered in magnetic fields? Well, those don't stay static. They constantly shift and change with the convection currents, and they can become twisted and tangled. When the magnetic field lines get too twisted, they snap like an overstretched rubber band and release a burst of magnetic energy. If this happens over a sunspot, the result is an explosion on the sun's surface called a solar flare. The biggest flares can be millions of kilometers wide and reach temperatures of over 50,000 degrees Celsius. At that size, they're big enough to blot out the entire Earth. When a solar flare occurs, it ejects enormous amounts of plasma from the sun's atmosphere in every direction. These clouds of charged particles travel at speeds of up to 1,800 kilometers per second, about 6.5 million kilometers per hour. That's more than 6 times the speed of sound. Now, there are different classes of solar flares based on their size and brightness. The smallest ones are called a class and are about 100 times smaller than the largest ones, called X-class. But even the smallest flares can be dangerous. Each one gives off a burst of electromagnetic radiation across the entire spectrum, including radio waves, visible light, and X-rays. It's the radio wave and visible light portions of this radiation that we use to classify their brightness and assign them their letter designations. Flares also give off a surge of plasma, but it's not always directed at Earth. In fact, scientists only started seriously tracking solar flares in 1859 after a huge flare caused a global disruption of telegraphs. Since then, we've seen a lot of flares. And when they do erupt towards Earth, our planet's atmosphere protects us. High-energy particles slam into the upper atmosphere and collide with molecules. These collisions excite the molecules, boosting them to higher energy levels. Eventually, these excited molecules release their extra energy as light, creating a beautiful display of northern and southern lights. But while we may find auroras beautiful, they're a sign that our telecommunications and power grids are in danger. See, it's not just light that solar flares give off. They also emit a stream of charged particles. If the flare is big enough and pointed in our direction, the resulting shockwave can reach Earth in as little as 8 hours. Our planet's magnetic field normally deflects these particles, but some still make it through and enter the atmosphere. There they collide with gas molecules and strip them of electrons. Those free electrons flow toward Earth's surface and build up in the upper layers of the atmosphere, forming a sort of giant cloud that blocks radio signals. These disruptions can fry unprotected electronics and knock out radio communications for hours or even days. They can also damage satellites. For example, in 2009, an X-class flare disrupted communications with several GPS satellites, highlighting a problem with our growing reliance on space-based systems. In 2021, a solar storm destroyed 40 newly launched Starlink satellites. And in 2022, a powerful geomagnetic storm caused by a solar event knocked out 40 newly launched Starlink satellites. And the outlook for the future isn't great. You see, as our society becomes more technologically advanced, we become more dependent on satellites for communications, navigation, and other services. And right now, we're overdue for a big solar storm. Every 11 years, the Sun's activity goes through a cycle where the number of sunspots and frequency of solar flares increase until the activity peaks. Then the process reverses until we're left with a calm and quiet sun. We're currently approaching the peak of activity in this cycle, which began in February of 2019. This means solar storms are likely to become more frequent and more powerful, which is why scientists are constantly searching for ways to better predict and track these events. They're working on new instruments to monitor the sun and improve our understanding of space weather. But there's only so much we can do to prepare. Solar flares are chaotic and unpredictable, making them impossible to forecast with 100% accuracy. And with over 30,000 satellites orbiting the planet, there are countless potential points of failure in our technological infrastructure. So here's what you should take away from all of this. The sun is an awesome ball of burning plasma that occasionally explodes. When it does, it sends out a shockwave of energetic particles that can wreak havoc on our technology. We're overdue for a big solar storm, and there's not much we can do about it. Don't worry though, because the worst that could happen is that your Starlink internet gets knocked offline for a few days. At the start of the video, we mentioned that solar flares can sometimes be really big. We'll tell you about the biggest ones ever recorded next. While modern science has helped us understand the forces at play during solar flares, we didn't always know what caused them. Back in 1859, astronomers were completely baffled when they saw a bright flash on the sun. It looked like a new star had suddenly appeared in the sky. They named it the white light flare because it gave off a bright white glow instead of the reddish color we normally associate with solar flares. It turned out that this event was 300 times larger than any solar flare recorded since part, and the cause wasn't a simple magnetic reconnection. Instead, it was an immense eruption called a solar tsunami. Unlike regular solar flares, tsunamis occur when magnetic field lines anchored by sunspots suddenly collapse. As a result, they release a huge amount of magnetic energy and plasma. This outburst can trigger an intense shockwave that blasts outward from the sun. If it hits Earth, the shockwave can compress our planet's magnetic field, pushing the Van Allen radiation belts closer to Earth. This exposes us to higher levels of cosmic radiation, which can interfere with satellites and communications. In 1859, this event disrupted telegraph systems around the world. A century later, we weren't totally caught off guard. We knew there was a good chance something similar would happen again. So, in 2012, NASA launched the Solar Dynamics Observatory, which constantly monitors the sun for signs of solar tsunamis. And 2 years later, the hard work paid off. The observatory captured images of a solar tsunami nearly 10 times larger than the 1859 event. Thankfully, it wasn't aimed at Earth. However, scientists realized that such an event occurring every 100 years could pose a serious threat to modern society. Imagine if a solar tsunami hit Earth when the magnetic pole shift weakened our planet's defenses. It could potentially destroy every electronic device on the planet and throw our society into chaos. It sounds like a sci-fi movie plot, but this possibility is very real. Even without a solar tsunami, our planet's magnetic field is getting weaker. Magnetic poles shift every couple 100,000 years, and we're currently due for a reversal. And while previous shifts haven't significantly affected life on Earth, scientists think it could be a different story this time. You see, the weakening magnetic field allows more cosmic radiation to reach the surface, increasing the ionization of our atmosphere. More free electrons means more radio interference. And if the timing is unlucky, a solar storm could knock out our grid and telecommunications for months or even years. Of course, humanity has endured challenging times before and will make it through this one too. But that won't stop me from prepping for the worst, just in case. We've got everything you need to get through anything life throws at you, from food and water storage to emergency food kits and survival gear. Check it out.